So we would like to find the direction of fastest increase for the function f of xy equals ln of 2x minus y squared at the point 5, -3, in particular, the unit vector that points to that direction. And we would also like to find the rate of change of f in that direction at the same point. So let's first of all try to understand what we're looking for here. So we have a point AB, and we would like to find the direction in which f increases the fastest. And what we know is that if the gradient, as long as the gradient is non-zero, the direction that we're looking for is the direction of the gradient. So all we need to do is just take the gradient and normalize it. So that would answer the first question. So what we need to do is take the gradient, normalize it. As for the second part, what we need to do when we want to find the rate of change is precisely the magnitude of the gradient. So what we want to do is find the gradient at that point and normalize it. That will give us the direction of fastest increase. And then we want to find its magnitude. I mean, we will have already found its magnitude by that point, and that will give us what the rate of change in that direction is. So let's do it. Let's find the partial derivatives. Those will be 1 over 2x minus y squared times 2. And if we plug in the points that we were given, so the point that we were given, 5, -3, has been chosen so that the numbers look nice. So we get 10 minus 9, that's 1. So the denominator is 1, and this will be simply equal to 2. And then let's find the derivative with respect to y. That is going to be again 1 over 2x minus y squared. This time we have to multiply by the derivative of 2x minus y squared with respect to y, which is -2y. So that will give us that f sub y at 5, -3 is equal to 6. So this tells you that the gradient at 5, -3 is equal to 2,6. And we would like to normalize this. Here, there's a very interesting thing that it's worth knowing. That so let me write it down. So we wish to normalize to 6, right? So normally, you know, this means divide by the magnitude of 2/6, which is a pretty simple thing to do. However, there is something that if you know it, it can make your life easier. When you normalize a vector, you can actually choose to normalize any positive multiple of it. It's the same thing. Again, you don't have to use this, but I'm saying that it's quite interesting as normalizing one, 3. And the magnitude, of course, of 1, 3 is square root of 1 squared plus 9 plus 3 squared. Which is square root of 10. And so the unit vector we were looking for will be simply 1 over square root of 10, 3 comma square root of 10. You would have found the same thing had you normalized to 6. So that's the first part. Now, for the second part, we have to be careful. We want to find the magnitude of 2/6. So that answers the first part. For the second part, we want to find the magnitude of 2/6. Okay, it has nothing to do with normalization here. So this is going to give us square root of 4 plus 36, this being the squares of 2 and 6, which is square root of 40. So that's the answer to the second question. The rate of change in the direction of fast increase is square root of 40, and the direction of fastest increase is given by the vector 1 over square root of 10 and 3 over square root of 10. I do want you to understand that if you have ignored this little trick that I used, which maybe you should have ignored it, you would have found simply 2 over square root of 40 and 6 over square root of 40. A moment's thought will show you that these are exactly the same vectors, simply because square root of 40 is the same thing as 2 times square root of 10. Okay, so if you write square root of 40 as 2 times square root of 10 and you do the simplification, you will find exactly the same thing. So that completes our problem. Thanks for watching.